On June 26, 2020, at 12 a.m. GMT, a CoSpace Rescue Challenge map was issued to iCooL participants from around the world. All participants were given 24 hours to develop AI strategies to solve the same challenge. In CoSpace Rescue Challenge, teams are required to build a real robot, develop and program appropriate algorithms and strategies for both real and virtual autonomous robots to navigate through both real and virtual worlds. Additionally, they have to search and collect objects while competing with another team's robot that is also searching and collecting objects in the same real and virtual worlds. During the challenge, the robot needs to overcome barriers, avoid traps, and swamps. If the robot successfully makes a deposit, the points of the objects deposited will be doubled. For University and U19 category, the CoSpace server will send the robot its own coordinates while the robot is searching in the virtual world. The location information can be used for the development of AI algorithms and strategy such as path planning and search algorithms. Additionally, for University and U19 categories, there are signal block zones which are surrounded by pink dotted lines. When a robot enters the signal block zone, its coordinates information will be blocked. The winner of the challenge will be the robot with the highest points.
Hello, I'm Kaoru Muto, Japanese junior high school student. I'm not good at English, but I hope you can listen to the end. I live near Osaka. Osaka is the second biggest city in Japan. I began robot programming at 6 years old, inspired by my brother. So I enjoyed soccer and line race to 11 years old. I like soccer so much, and I won some prizes. I did rescue simulation as my brother's teammate since 11 years old. At first, it was difficult and I had to hit many keys, so I didn't like it. However, my score was better with my device and I began to think it's fun. Now I love CoSpace. This time, tried to make a program by C language for the first time. After many trials and errors, I was so happy to get the max 2980 on this map. My strategy on this map is the following. First, my robots go to many black objects area from the start point, and when my robots get out of it, my robots make another round if not black. If my robots have one black, my robots go to location 4, which the most cyan, and then go to location 5 and 6, which the most red. Then my robots tried pass through the cyan area to number 7, near the collection box. When my robots arrive at number 7, if I have 5 or more objects, my robots go to the collection box and return to number 5. After deposit, my robots go back to number 7, then number 9, then through the red objects to number 10. And my robots go to number 11 and go to number 12 and number 13 through the cyan object. From there, my robots go through the place that don't reach the first set and go to number 0. Then, like the first, my robots go to 21 and go to the collection box. After this, my robots return to the beginning and repeat. By the way, each place to go is randomly chosen from the decided range, so it doesn't go exactly the same way. It's my strategy on this map. I will do my best to speak more smoothly at the next English presentation. Thank you for listening.
My name is Ray, also known as AU7001. In the last competition, I got a lucky 3,500 score to keep me in the race. Now, what was it that got me here? Am I just better at others? Did I cheat, or did I just got lucky? Here's the strategies that I used to get a better score. When everyone is given with the same parts of data, there are a lot to explore with. But given with the same information, it is still a limited amount, so there will be similar ways teams will try to win, and the most important way is using pathfinding algorithms. It's important to know that there are only a few available algorithms for pathfinding, and also some are just better than others in this case. For example, DFS, BFS, Dijkstra's algorithm, Greedy, and A*, all are common pathfinding algorithms. Breadth first search finds its path through layers starting from its starting point, and depth first search finds its path only using one point and all the way down. These two can find all the possible ways from A to B, but takes up a lot of memory and time, which is critical to rescue. For my program, I am using A* because it's a combination of both Dijkstra's and Greedy, which performs better than just one of them. One of my major strategies is to use the super boot. My program takes on the closest object area that fits its need to make a super boot. This allows the robot to get consistent super boot to maximize the score. At first, our robot is going to take 2 red, 2 cyan or blue, and 2 black to create a super boot. After that, I can use the super boot as red, blue, or black to create another one. This allows the robot to have a choice for the object it chooses, and also gather more object in a shorter time with the rhythm going. All this code is really complicated and would be near impossible to write thousands of data in a limited amount of time. So I used a little program to write it for me, where I input the map data with coordinates of the wall, traps, swamp areas, and deposit areas, and also the object areas where the robot will search in for objects. This allows the program to be done in just minutes instead of hours, so I can improve on other places. The map allows the program to go to deposit areas, move to object areas, and avoid swap areas. For no signal places, I have a variable for the last coordinate of the robot, which can be used as a backup when the robot enters it. It's obvious that I've been around in CoSpace Rescue for a good amount of time, so let me introduce myself. My name is Ray, and for this particular CoSpace Rescue competition, I am representing Australia. Through my last 4 years of rescue competition experience, starting from U12 and now U19, with the new possibilities opened up with coordinates and with the help from instructors, I've participated in both international and national competitions. I may have not listed all of them. Problems, issues I still face. Despite all the changes and experiences I had with CoSpace Rescue, I still face challenges. The first one is ignoring borders and traps. I believe this problem is caused by long run times of the algorithm, or maybe I designed the map poorly. This could be fixed by changing how I designed the map. However, the problem can still occur. A map with scattered objects doesn't fully express the advantage of my code, so more of it would depend on luck. Hardware is also a big problem because the algorithm requires going through lots of data with calculations. When the robot is calculating the shortest route for a long distance, it could go in circles or run into traps, with CoSpace running at a low FPS. The last problem is one of the unluckiest where I have encountered, which cost that competition. This one is mostly based on luck where the super spawns inside a trap. When the robot goes to get it, I could program it to dodge the trap, which would make it hard to get it, or I could program it to ignore the trap and let it thus get it, which can allow the robot to thus run inside the trap after it collected the super. There's no current way I have a solution with this, but I'm still brainstorming ideas. At last, I am really thankful for this opportunity, even with the pandemic changing schedules.
And off we go! Red Robot entered the black object area, and the black object is worth 20 points. In this demo game, we will minimize any manual intervention. Red Robot is depositing. Red Robot has a set of red, black, and cyan objects. It can generate a super object. Blue Robot is depositing. Red Robot is searching in the blue special area. Any objects picked up in this area will double in value. Blue Robot picks up super object. That's 90 points. Red Robot entered the black object area, and the black object is worth 20 points. Blue Robot is searching in the blue special area. Any objects picked up in this area will double in value. Red robot is depositing. Blue robot is depositing. Red robot travels out of the boundary. System resets it back to the field and freezes it for 10 seconds. Blue robot is calculating its path. Blue robot has picked up a super plus object, that is 180 points. Blue robot is searching in the blue special area. Any objects picked up in this area will double in value. Red robot picks up super object, that's 90 points. Red robot is depositing. Blue robot travels out of the boundary. System resets it back to the field and freezes it for 10 seconds. Blue robot is depositing. Blue robot has a set of red, black, and cyan objects. It can generate a super object. Red robot entered the black object area, and the black object is worth 20 points. Red robot is depositing. Red robot has a set of red, black, and cyan objects. It can generate a super object. One minute left. Blue robot is leading. Red robot is depositing. Red robot has overtaken blue robot. Blue robot is depositing. Blue robot has overtaken red robot. Blue robot wins this challenge. Congratulations!